hydraulic oils constitute an important component in the operation of various machinery types. Agricultural machinery, tractors, forklifts, industrial equipment, presses, machine tools, dump trucks, and municipal vehicles. The operational conditions of modern hydraulic systems are constantly becoming more complex. The designs are getting more compact, the filling volumes are decreasing, the channels and gaps are becoming thinner, and the equipment often runs continuously under high loads. At the same time, hydraulic fluids are subject to increasingly stringent requirements. They shall ensure wear protection, oxidation resistance, compatibility with various types of seals, and maintain a stable viscosity. In most cases, machinery manufacturers require oils to be used in accordance with DIN 51524 regulations, which stipulate compliance for a number of parameters, including the moisture content. This requirement is for a good reason, because hydraulic oils are prone to water accumulation. Moisture can enter the system due to differential temperatures. After heating up during operation and then cooling down, the machinery draws in moist air, and moisture accumulates by way of condensation inside the tank if there is no proper evaporation. When the equipment operates in a humid environment or is exposed to significant temperature fluctuations, the risk of oil contamination with water increases many times. Water in oil not only deteriorates its lubricating properties, but also causes corrosion of metal parts, accelerated aging of additives, emulsion formation, cavitation damage, and eventual failure of hydraulic system. According to DIN 51524, oil change is mandatory when the moisture content exceeds 0.05%. However, dehydration and reuse of hydraulic oils is more cost-effective than their change for new ones. The typical oil dewatering methods involve settling or centrifugation. However, implementing such techniques consumes plenty of time and energy. Moreover, it is not always possible to achieve the required dehydration level. In view of the above, GlobeCore has developed a comprehensive technology for removal of moisture from hydraulic oils, which involves the use of the equipment that ensures maximum efficiency, depending on the amount of moisture. If the moisture content of oil does not exceed 100 parts per million, an CMM-LT thermal vacuum dehydration unit will be the best choice. Owing to a combination of heating and high vacuum, these units efficiently remove both dissolved and free water, reducing its content to 10 parts per million and even to a lower point. Additionally, they ensure removal of particulate matter, which often contaminates hydraulic oils, up to purity class 14/12 as per ISO 4406. The CMM-LT units are easy to operate, compact and mobile, which greatly facilitates their use. The range of units is represented by models from 0.6 to 8 cubic meters per hour. In cases where the moisture content of oil exceeds 100 parts per million, GlobeCore recommends using ZP130 or ZP260 units with a capacity of 4 cubic meters per hour. These systems operate on the basis of physicochemical adsorption, wherein zeolite serves as an active material that absorbs moisture. The advantage of this technique is a high efficiency with no oil heating and at low operating costs. The use of zeolite cartridges ensures deep dehydration even at a high oil moisture content. Furthermore, GlobeCore professionals have developed BRZ units that allow for repeated reclamation of zeolite without discharging it from the cartridges, which saves money and offers favorable environmental impacts. If oil has a very high moisture level, 50% or greater, the best solution is to use an CMM-CF plant based on coalescing filters. As the oil flows through a coalescing filter, water molecules combine into large droplets, which are easily separated from the oil and accumulate in a special tank. The next step is moisture removal through a drain valve, which allows for quick dehydration of even heavily water-cut hydraulic fluid. In addition to dehydration, CMM-CF is also capable of removing the particulate matter. In this case, the filtration fineness is customizable and may range from 1 to 25 microns. GlobeCore technologies can be combined for achieving the maximum dehydration effect, A plant with coalescing filters or a Zeolite cartridge unit is used first for coarse water removal, and a thermal vacuum dehydration unit can perform final processing to the required parameters. The timely use of GlobeCore technologies helps in maintaining the hydraulic system's operability, as well as considerably extends the equipment's service life, reduces the repair costs, and improves the overall production efficiency. And how do you solve the problem of water-cut oils in hydraulic systems? Share your experience in the comments section. More information on the GlobeCore technology and equipment for hydraulic oil dehydration can be found by following the link in the first comment or visiting our website, www.globecore.com.